Hello everybody, today I'll be showing you how to write a program to expand binomials in your graphing calculator. So the first thing you have to understand is the Binomial Theorem, which is shown to you in the bottom right hand corner of your screen. Now in this program we are going to expand the binomial in the form of ax plus by to the n. So it doesn't make too much of a difference, just has a couple more coefficients we have to worry about. Alright, so first thing we're going to do in the program, well, first you got to create the program. I name mine Binomial, short for binomial expansion. Name whatever you want. I don't care. But the first thing you have to do is output what it is that we're going to be doing, so the user knows how to input variables, what variables we're going to ask for. All right, so let's go ahead and output 8, 1, parentheses ax plus by to the n. And if you're not familiar with the output command, basically 8 is the line. The first argument is the line. The second one is the column. So 8.1 is going to put it in the bottom left-hand corner of the home screen. All right. Next, we're going to want a prompt for the three variables a, b, and n. So let's go ahead and do that. A, comma, b, comma, n. And then after we do that, we just want to clear the home screen again, get that clear. And now we want to initialize the variable L. Alright? Well, L is going to store the line that our current term is going to be displayed on. Alright? It'll make sense a little later once we get into the displaying part of it, but for right now, just initialize it to 0. Alright? And now what we have to do is open a loop so that we can loop through each term that we're going to expand. So we're just going to keep going through the binomial expression, and we're going to expand it term by term. Alright? So open up a for loop and store at k, start at 0, and we'll go all the way to n, which is our exponent. Alright? So the first thing we're going to want to do is add 1 to L, and then store it back as L. And what this is going to do, notice how we stored it, when we initialized it, we stored 0 as L. But now we want to add 1. So for each time that we go through the for loop, we're going to go to the next line, because we're going to use the variable L to determine what line our output's on. So each time we're going to go to the next line. Alright? So store that as L. And now we're going to want to calculate all of our coefficients. Alright, and as you can see, the bottom equation, where nck equals n factorial over n minus k factorial times k factorial, we're going to want to solve that. Alright, so let's go. N factorial is math, PRB 4, factorial sign, divided by 2 sets of parentheses, open up 2, n minus k, close parentheses, to the factorial, factorial, and then times k factorial. Alright, and we're going to store that as C. Now you don't have to do that. You could do all of this in one big line, but I think it's a little more clear if we divide it up. It takes a little bit more memory, but who cares? We're not too concerned about that right now. Alright, so let's take C and multiply it by A to the open parentheses n minus k, close parentheses, times b to the k, and store that, which is our final coefficient, as d. Alright, and that is taking the two coefficients that were entered and putting them as the coefficient of each term. Alright, so now we're going to want to do a little check before we output onto the screen. Alright, so remember how that L, each time we go through the term, L is going to add 1. Now there are only 8 lines on the screen, so if L equals 9, then we're going to have a problem, and we're going to get an error because it won't be on the screen. So we want to do a quick check to see if L equals 9. So go ahead and open a for loop. right at the top. If L equals 9, then we're going to pause so that the user can look at all the terms that are currently displayed on the screen before moving on. Then after he presses enter, we can clear the home screen, reset our variable L as 1. Alright, and then we can continue and display the next terms. Alright, continue through our for loop. And now we want to have our output. Alright, so we're going to just display each term on its own line. Alright, so let's go ahead and open an output command. And we're gonna start it on line L, and then we're gonna go to first character slot, and we're gonna put in our coefficient. All right. The next one, the next part of our term, still on. That's not output. Output, still on line L, and we're gonna leave some space for our coefficient to be displayed, so we're going to give it some room and put this next part at 6. Alright, open up a text string and say x raised to the, and then we're going to put our variables, our exponent here, and the next one still on the same line, give it 2 spaces, so x to the n minus k, that is the first exponent, and then we're going to multiply that again by, still on line L, leave some space. The next one is going to be y raised to the, and then the y exponent, still on line L, 2 spaces, k. Alright, so there we have all of our output. Wait, oh, there's one more part. Now, each time we go through the term, it's going to be added to the following term. Alright, but the last term does not have anything after it. So we want to check to see if we're on the last term, and if we're not, then we can go ahead and add a plus sign after the term. Alright, so do another quick check. If k does not equal, second math, does not equal k n, so that checks to see if we're on the last time we're going through a for loop, and if we aren't, then output L comma 14, still on that same line, then I'll put a plus sign. Alright, then we can end that quick little if statement. Alright, and we can also finish our for loop because we finished everything in that, so end that. And now we can pause one more time so that the user can see the last couple variables, so add in a pause, it's 8. And then once he presses pause, the user can, then we can clear the home screen, and then stop. Alright, that was F. Alright, so there you have it. That is all of the binomial expansion program. So now let's go ahead and test it. Let's test it. Let's just use Pascal's triangle here. Let's see if it works. Let's go 5. Boom, boom, boom. Look at that. Pascal's triangle. Alright, so, and our program works. Thanks for watching, and be sure to give me a thumbs up, subscribe to my videos. Thanks.